Good morning one more time. We're going to start with the do now. These are a couple of questions from chapter 5. We're going to start with number 2. So if you haven't had a chance to get it done yet, that's fine. Make sure that you go back and you try to do it. If you have gotten number 2 done, put in your answers for A and B. Which element in each of these pairs has the lower ionization energy? So if you didn't get a chance to do it, I'll help you out a little bit. Oops. So this is one of those questions where it asks about the trend. For ionization energy, when you're going from the bottom to the top of a group, the ionization energy increases. And likewise, when you're going across the period from left to right, it increases. Cesium is below rubidium, so it is going to have a lower ionization energy. And sulfur comes before chlorine in the period, so it is going to have the lower ionization energy. So just wanted to give a little practice there. Now we're going to talk about question number 1. So if you were able to get number 1 done, you can put in your answer for that. I see that we have, so let's see. Which one of the following is not isoelectronic with krypton? A, B, C, or D? And we're going to go over this. I have a periodic table on the next slide. You can also say help if you had a couple of minutes and you're like, nope, don't know this one. Okay. So let's go over it. We were talking about selenium, bromine, zinc, and forgive me my memory, okay, and strontium. Is that it? Yes. Okay. It's still early for me too, y'all. I made the question. Couldn't remember the answer choices. Okay. So isoelectronic means that it has the same number of electrons. And I gave you a list of ions. That's not the same order. Don't worry about it. We talked about electron configurations of positive and negative ions. And what we said for positive ions, like strontium, is that it's going to look like the noble gas in the period above it. Strontium is here. Struggle day. Strontium is here. The noble gas above it, in the row above it, is krypton. Zinc, we didn't do a whole lot with the transition metals, but zinc has 4s electrons. It's got 3d electrons. It's also, when it loses those 4s electrons, it's going to look like argon. That's not krypton. So we already know just from checking the positive ions, zinc don't smell right, but let's keep going. Selenium and bromine, they're going to gain electrons. And I'm writing this out so you can have it. Ng is noble gas. For the negative ions, they're going to gain electrons, and they're going to look like the noble gas in their period. So selenium and bromine, when they gain those extra electrons, they're also going to look like krypton. So this is a practice in knowing your electron configurations and being able to figure out which noble gas that ion is going to look like. Make sure that you can do a question like this. That's why I put it up. So if you need help, office hours, if it's something quick, like 5 minutes, I can do that right after class. So if it still doesn't make sense, let me know after class. Fair? Okay. This week, we're covering Chapter 6. No real math here, but you have to memorize some rules. We're talking about the language of chemistry, so naming compounds, classifying compounds, and writing chemical formulas. The first thing we're going to review, which I hope you had a chance to watch the video. If not, I get it. Y'all just had an exam. So, struggle. We're going to talk about how you classify inorganic compounds and acids. So we've got 3 major groups: ionic, molecular, and aqueous acids. You can break each of those down further, and these are the 5 that we're going to be focusing on for this chapter. Now, word to the wise, there are other naming systems out there. Plenty of other ones out there. Common names, different conventions, etc. The only ones that we're testing for, so when you do your homework, chapter check-in, exams, the only one that we're testing for is the one that we're talking about here. So when you're doing your homework, don't be tempted to Google it, because Google will tell you 5 other answers. You don't want to get it wrong just because you put a name from a different naming system. So make sure that you stick to the rules that we go over in class. Okay. With that out of the way, I'm going to write down the different abbreviations that I use for this, so that hopefully you can put it down in your notebook. So I'm going to write the abbreviations. I would like it if you could write that down too, or take a screenshot, so that when I write my abbreviations or you see them in the title, you're not like, wait, what are we doing? So here we go. For ionic compounds, there's binary ionic compounds. So that's BIC or BICs. Ternary ionic compounds, TICs. So those are the 2 ionic compound classes we're going to cover. We're also going to cover one class of molecular compounds, and those are binary molecular compounds. I'm going to call them BMCs. Now, I'll probably use the full names when talking about it, but when writing things down, it's kind of a lot to write. And for aqueous acids, we have two types: binary acids, or BA, okay, and ternary oxyacids, TOA. So let me know when you have this down in your notes, because you're going to need to reference this throughout the lecture. So I'll give you a minute. You can just let me know when you're ready to move on. We ready to move on? Does everyone have this down in their notes? Or at least a screenshot? Alrighty. So I'm going to, on this slide, break down what each of these inorganic compounds contain. So we're talking about metals or nonmetals and that kind of thing, so that we can classify compounds. This is a very abbreviated version. So if you have not had a chance to watch the Chapter 6 lecture, make sure that you do, because I have slides for each one of these classes. But this will at least kind of give you a little bit of a cheat sheet that you can use. So for binary ionic compounds, they're always going to have two elements, one metal, one nonmetal. An example of a binary ionic compound is table salt, NaCl. So Na, that's sodium, that's a metal, and Cl is chlorine, that's a nonmetal. So you're going to need to remember which part of the periodic table is metals, which part's nonmetals, because that's absolutely going to be needed here when you're classifying compounds. Ternary ionic compounds, similar. You're going to see more elements though. You're going to see 3 elements. You're going to see at least one metal. And you're going to see at least one nonmetal. And it'll become a little bit clearer as we move on. The other way that we can describe this, which is more helpful, but it won't make sense until we cover this other class, is that it's one metal plus a polyatomic ion. Anion, to be exact. So write that one down. It's not going to make sense yet. That a ternary ionic compound, it has 3 elements, one metal plus a polyatomic anion. We're going to cover what a polyatomic anion is a little bit later. Binary molecular compounds have 2 elements. So whenever you see the word binary, think 2. Whenever you see ternary, think 3. So for binary molecular compounds, you're going to have 2 elements. They're both going to be nonmetals. I did not give you an example. So an example for a ternary ionic would be sodium nitrate. Binary molecular, an example would be water. Hydrogen and oxygen are both nonmetals. A binary acid, again, binary, think two. There are two elements. You're always going to have a hydrogen plus a non-metal. You'll also see in parentheses an AQ after it for aqueous. In the last class, we have our ternary oxyacids. That's going to be a hydrogen plus a polyatomic anion, which again will make more sense shortly. It will also have that AQ after it. So acids will have that AQ for aqueous. That's one of the ways that you know you're looking at an acid, and you have to figure out which type, binary or ternary oxyacid. So let me know when you're ready to move on from this slide, because you're going to need to jot these down so we can go through and do some practice together. And it's okay if you don't get it all right away in terms of being able to classify. We're going to walk through it and I'm going to ask you questions about each compound to help you figure out a method that works for classifying compounds. So let me know when you're ready to move on, because this is kind of a lot to write in your notebook. How are we doing? Are we ready to move on? Excellent. So here we go. We're going to talk through some of these. We'll talk through maybe the first two, and then I'm going to let you try some of these with your notes. So here's my method. If it doesn't work for you, that's fine. But at least use it and see what works, what doesn't for you. So let's start with A. We have a chemical formula, CO2. You want to take note of how many elements do you see. So how many elements are in this molecule? Yeah, it's not a trick question. There's two elements. So it must be some kind of binary something, okay? So we've already narrowed it down. Are these metals, nonmetals, or a combination of the two? They're both nonmetals. So then you look at your notes for now and say, okay, I've got two elements. They're both nonmetals. Where does this fit? So take a second and look. What type of compound do you think this is? And you can use my abbreviations. It'll make your life easier. We're looking for a compound, yeah, that has two nonmetals. The only thing that fits that is a binary molecular compound. So that's classifying. Let's go on and do B together. How many elements do you see? And do we have metals, nonmetals, or both? Yeah, y'all already know. I'm going to ask the same questions every time. We got both. So we've got nonmetals and we have a metal. So we've got two elements. We've got one nonmetal and one metal. So we know it's got to be a binary something. And because it's one nonmetal and one metal, that tells us exactly what it is. So look at your notes. What kind of compound is this? Binary ionic compound. So I'm going to give you, we'll start with 3 minutes, and then I'll check in with you to see if you need more time. I want you to try classifying these last 3. So do C, D, and E. And I'll check in about 3 minutes. All right, how are we looking? Are we ready? Do we need a little more time? All right, well, let's get started. So for C, it'll be a little bit easier for you to classify this one once we've gone over polyatomic anions. But you can see that it starts with an H. It has aqueous, so that means it must be some type of an acid. It's got more than just one nonmetal, so it's got to be a ternary oxyacid. For D, what did we get? What kind of compound is D? I agree. It's a binary acid. We've got the hydrogen plus a nonmetal. And it has that aqueous at the end. What about E? What kind of a compound is E? It's a ternary ionic compound. We've got a metal plus 2 nonmetals for a total of 3 elements. So the number of elements keys you in that it has to be something ternary. And there's only 2 choices, ternary ionic or ternary oxyacid. Since you don't see a hydrogen or aqueous, it can't be an acid. So it has to be a ternary ionic compound. So how did those feel? Does it feel like something like, yeah, I can do this, just got to practice? Or is it like, nope, not for me, still not getting it at all? Good. Good. So that was classifying inorganic compounds and acids. Now we're going to talk about ions. Some of this is going to be a review from chapter 5. If it's not a review, take note of that. Let me know at the end, and we can get you some help. Or you can go back and look at the Chapter 5 lecture, look at your notes, that kind of thing. But make sure that the things that I say are review are actually review. Okay. So we're going to introduce a little bit of terminology here. We've got this big, broad category of ions, which we can break up into cations and anions. Cations are positively charged ions. Anions are negatively charged ions. So when we talked about these in Chapter 5, we didn't put those terms to it yet, but now we are. Within these groups, you can have monoatomic or polyatomic ions. Monoatomic just means that there's one atom. So an example of a monoatomic cation would be Na+. It's one atom, it's positively charged. Polyatomic means two or more. The only polyatomic cation is ammonia. So there's the difference, monoatomic versus polyatomic. Now, when we talked about positive ions, what we really said is that what we're looking at is metals. Because metals lose their valence electrons and become positive. For anions, we're talking about nonmetals because they gain electrons to form ions. Now, don't worry if you don't have all this down yet. I'm going to talk about cations and anions separately. So I'm going to review some of this information already that's on this slide. So we're first going to talk about monoatomic cations. And as I just said, we're talking about metals here. Metal atoms lose their valence electrons to form cations. That's something we already knew. We just didn't know the word cation. So this is review. The group number for your metal tells you the ionic charge when we're talking about the representative elements. And those are the ones that have the A after it. So that, again, should be review. To name a cation, you just take the name for the parent atom that's on the periodic table, write that down, space, and then write the word ion. So for example, Ca, you look that up on the periodic table. It's a representative element. Great. So the way that you name it is by writing the name of the atom, calcium, followed by the word ion. So how would you name the second one? FYI, I always have a periodic table. I didn't put an announcement or anything like that, but you need a periodic table for the rest of the semester. So every time you log in for class, make sure you have a periodic table because you're going to use it. So this is the lithium ion. Pretty simple. But we've got more than just representative elements that are metals. We have transition metals that are in the D block. And those metals can form multiple cations. So we're not talking about just one charge here. We have to tell our reader what charge this ion has when we're writing down a name. And for that, we're going to use the stock system. So you write a Roman numeral after the atom name that tells you what the charge is. There are some exceptions. So zinc, silver, and cadmium only have one charge. Those three are transition metals, but they only have one charge. So you don't have to put their charge in parentheses. So what I mean by putting a Roman numeral, I'll show you. We have Fe3+. That is a transition metal. It's in the 3D. And the way you name it is by writing out the parent atom just like you would for any other metal or any other cation. But in parentheses, we're going to put the Roman numeral 3. And that tells you the charge. 3+, you got 3 in parentheses, followed by the word ion. And just so that you have some Roman numerals, I did this in the video too. But we only use Roman numerals like that. I learned this in school, like elementary school. But I don't even know if they teach this anymore. So those are your Roman numerals up to 6. You shouldn't need anything past that. So let's try one. Oops, not chromium. So try writing this one using the stock system. So I'm telling you already, it is a transition metal. It has more than one charge. So write the name of this ion using the stock system. I absolutely agree with everyone who has chimed in. So this is the mercury 2 ion. Now there is a mercury 1, and I want to show you what that looks like because it looks a little funky. So it's Hg2 with the 2+. That's mercury 1. So you may want to jot that down. You don't see mercury 1 just alone. It's always mercury 2, 2+. That is its ion. So whenever you see a compound that has mercury 1 in it, it's got 2 mercury 1 atoms. So this is just a a weird little exception that I wanted to introduce you to. So make sure that you know that. Now there's another system that I'm not going to cover in this live lecture, but I covered it in the YouTube lecture, and that's called the suffix system or the Latin system, where instead of putting a Roman numeral, you're writing the suffix ic, or ous, us, to designate the ion with the higher charge or the lower charge. Not a fan of that system. It's not as descriptive as the stock system. I won't be testing you on it, but you may see it in your homework. So make sure that when you go to the YouTube lecture that you take note of that. So don't think this is the only one for writing names for transition metals. It's just not one that we're going to do a lot of work on. But if you have to take chemistry, especially chemistry with a lab, you're going to see both of these ways of naming. So you should be introduced to it. You should recognize it. But for our class, I'm not going to test you on it. So is everybody clear on that with the Latin system? Won't be tested on it, but it could be in your homework, right? Okay. So let's do some practice. I will give you 3 minutes, and I want you to name these ions. Notice that I'm not telling you whether or not it's a transition metal or not. So you need to first determine, is this a transition metal? If so, is it an exception? And then move on from there. So again, 3 minutes. Try to name these ions using the stock system or just the regular old naming mechanism for cations. I'll check back. Actually, I'll give you 2 minutes because this shouldn't take too long. So I'll give you 2 minutes and then I'll check back. Are we ready or do we need some more time? All right, well, how about the first one? CS2 plus. What did you name that? And it shouldn't be 2 plus. I can't believe I'm just catching that. It should be plus. Yeah, my apologies, y'all. So this one, cesium, it's not a transition metal. It's a representative metal. So we don't need to use the stock system. So it's just the cesium ion. What about the second one? What did you name that? So zinc is a transition metal, but it's an exception. So again, no stock system here. And what about the third one? This third one is definitely a transition metal. So we're going to have to use the stock system. So you put the 2 in parentheses after chromium and then write the word ion. So that's some practice naming cations. How do we feel about these? Now we're going to shift over to the anions. Let's get through the monoatomic anions in naming. And maybe we'll do a little bit of polyatomic ions, and then we'll take a break. So, monoatomic anions. We're talking about nonmetals that gain valence electrons to form those negative ions. The charge, you're going to take the group number and subtract 8. And we're talking about nonmetals in groups 5A through 7A. All of that should have been review in terms of the nonmetals and the charge that they gain valence electrons. So that's review. If it sounds like something you've never heard before, you need to revisit chapter 5. The way that we name monoatomic anions is by adding IDE to the root name. So that's kind of like the first syllable-ish of the element. So I'll show you what I mean. I'll name this first one here for you, N3 minus. N, you're going to look at your periodic table and see that's nitrogen. We're going to get rid of everything but the first syllable or the root. We're going to replace that with IDE. So that what you get is the nitride ion. So you always want to follow these with ion if you're naming an ion. Br minus, you're starting with bromine. That's the element name. What do you think the ion name is going to be? If I tell you, we're getting rid of the INE. What is our ion? It's bromide. Now don't worry. I am not going to make this a spelling exam. So when you do your exam 3, we're mainly going to be talking about multiple choice again, because some of the spellings for these things is a little bit funky, and I don't want you to get points off just because I can't figure out what you mean. So you'll need to know these rules, and for your chapter check-in, you will need to write these out. But I'm going to be a little bit lenient as long as I can tell that you know what you're doing. So don't give me like brominian or something like that. That's really wrong. So try to do your best with the spelling for the chapter check-in, but know that for the exam, it will mainly be multiple choice. So that was monoatomic anions. Now we're going to talk about these polyatomic anions. I abbreviate those PAA because that's a lot of words, okay? Too many letters, it's too early. Generally speaking, we're talking about one or more elements combined with oxygen. There are some exceptions for polyatomic anions, but by and large, we're talking about elements combined with oxygen. And the ones that are combined with oxygen are also called oxyanions. Now, I'm going to show you a table in just a minute that has all of the polyatomic ions. Because remember, there's one cation that is also polyatomic. You're going to get that chart for the exam. I'm not going to make you memorize them. But you do need to understand how they're named. Many of these polyatomic anions have a suffix ATE at the end. So NO3 minus is the nitrate ion. Notice how it's nitrogen plus oxygen. So it's an oxyanion. Some of them, though, some of these oxyanions have ITE. So NO2 minus is the nitrite ion. Anyone have a guess as to why we're using 8 versus ite? If you watch the video, you should know, or should at least be familiar. But what's the difference between nitrate and nitrite if you're looking at the formula? There's one thing that's different. So nitrate has a 3 and nitrite has a 2. Now let's not get, so this is not 3 minus. This is NO3, and I'll kind of exaggerate the subscript there. That tells you that there's 3 oxygens. Then you have the superscript with the minus sign. That's the charge. So nitrite or nitrate is -1 charge, okay? But the 3 and the 2, that is where the difference is. There's 3 oxygens here and only 2 oxygens here. So the ATE form has 1 more oxygen than the ITE form. That's the difference. They both have the same charge, though. Same charge, but a different... Oh, no, it's fine. It's early. It's early. So, same charge, but a different number of oxygens. The ATE form has 1 more oxygen than the ITE. Let's see if that makes sense by doing a quick sample problem. So the formula for chlorite is ClO2 minus. What is the formula for the chlorate ion? If the ITE has 2 oxygens, how many oxygens should the chlorate form have? It should have 3. And the charge should be the same. So you'll need to know the difference between the 8 and the ite. This comes in handy when we're talking about naming ternary oxyacids. So you will get a chart with this information, but you need to remember this. This is the chart that you're going to get for your exam. And I've also placed it. So if you notice, there's a PDF that's associated with this room now. It's just a PDF of this chart. So you can, at your leisure, go ahead and save that. You can print it out and put it in your notebook. I'll post it again with when it's time to take the exam so that you can print out a new one if you need to. So get familiar with this chart. So I'm going to say that we take a break here. We'll come back with classifying and naming these different compounds. So it is 9:02. Let's take a 10-minute break. Actually, it's about to be 9:03. Let's just say come back at 9:15 because we're doing pretty good on time. So do what you got to do. Take a break. And I will see you back at 9:15. All right, everybody, it's 9:15. So let's get on back to it. Now we're going to get into classifying and naming. And then we're also going to start writing chemical formulas from the names. So we're going to take all the stuff that we learned in the first part and apply it. So I hope y'all are ready. Here we go. We're going to talk about naming the ionic compounds first. So the binary and ternary ionic compounds. When you're naming an ionic compound, you're going to combine the cation name and the anion name. You're going to get rid of the word ion, okay? The cation is always named first, followed by the anion. So I'll show you how I name this first one. First thing you want to do is classify. So I see two elements. One metal plus one non-metal. So this has to be a binary ionic compound. Let me know if you're with me so far. I know we're just coming up off a break. Sometimes that transition is a little rough. So when you're naming these compounds, you're not going to be told what kind of compound it is. And you're not even going to be told, well, it's an ionic compound. So that's why I'm going through the trouble of classifying before I name. Now that we know what we have, we know the rules to use. We're going to name the cation, name the anion, and then smush them together. The cation is first, and that's always the metal. In the chemical formula, you're always going to see the metal first. Ba is barium, and it is a representative element. It's in group 2A. So that tells us how to name it. It's simply the barium ion. Now you've got to deal with the anion. I is iodine. For naming a monoatomic anion, you get rid of everything that isn't the first syllable and replace it with IDE. So that becomes iodide ion. So we've named our two ions. Now we have to smush them together. Barium iodide. because we get rid of the word ion when we're naming the whole compound. Do I need to go over that again, or does that make sense? All right, I got it one more time. So let's do it one more time. First thing you want to do is classify. We said that there's 2 elements here, so it's got to be a binary something. I've got 1 metal and 1 non-metal, so it has to be binary ionic. Now that I know what kind of compound I have, I know which set of rules to use. I have to name the cation and the anion and then smush those together. The cation always comes first in the formula and in the name. So our cation is going to be barium. Barium is a metal, and it's in group 2A. So that means we don't have to use the stock system. We simply write the name of the parent atom, which is barium, followed by the word ion. The second thing we have to do is name the anion. That would be the I2 portion. And it doesn't matter how many of them there are, how many atoms there are. We're just talking about, okay, we know that it's only 1 element. So it is a monoatomic anion. The rules for naming that anion is you take the name of the parent atom, which in this case is iodine, and you replace everything that's not the first syllable with IDE. So that first syllable is iode. Get rid of the INE and replace it with IDE. So iodide ion. To write the full name of the compound, you get rid of the word ion from each of your named ions and you smush them together. Barium iodide. Does that make more sense? Let's do one more example. The second one, we have 3 elements. And as you get comfortable with that polyatomic anions chart, you'll know that you have 1 metal plus a polyatomic anion. So this has got to be something ternary. And the only 2 options are ternary ionic or ternary oxyacid. Since this does not look like an acid, there's no hydrogen, no aqueous, it's got to be ternary ionic. So we classified it. Now we've got to look at our ions. We've got copper for our cation. Copper is a transition metal. It isn't one of our exceptions, so we're going to have to use the stock system to name it. Right now, we don't know what its charge is. We can't just guess. So we have to first identify what our anion is. Look at your chart and look for SO4. So if you have not clicked on that PDF yet that's associated with the class, you should. and find what SO4 is. I'm looking for the name of this anion. It's the sulfate ion. What's its charge? The charge is 2 minus. So don't forget that the charge is always going to be the superscript, which is above, and the number of atoms is going to be the subscript, which is below. So we've got sulfate which has a charge of -2, 2 minus. When you're looking at ionic compounds, the overall charge of the compound has to be 0. So if the sulfate ion has a charge of -2, that means the total charge coming from the cation has to be a +2. Does that make sense to everyone? The total negative charge has to equal the total positive charge in an ionic compound. Since the sulfate ion has a 2 minus charge, we have to have 2 plus coming from the copper. There are 2 copper atoms, so that must mean that each one of those has a charge of 1. So when we write that with the stock system, we write it copper 1 ion. Does everyone follow that? There are 2 copper ions, and the total positive charge is +2. So each one of those coppers must be +1. I'm purposefully going slow. So when we put this name together, we're going to take the copper 1 and smush it together with the sulfate. So it's copper 1 sulfate. We get rid of those words, the ion. That's naming ternary ionic compounds. Let me know if you need to run through that again or if you're ready to move on. Yeah, we're going to do some more examples. I've got more on the next page. So if you just want to do more examples, we can walk through those together. Before we start naming these, let's classify them both. So take a minute and classify each of these compounds. What kind of compound is this first chemical formula? Ternary ionic compound. You see a metal plus a polyatomic anion. There's a total of 3 elements here. What about the second one? It's a binary ionic compound. There's only two elements, so it's got to be some kind of binary. And we see a metal plus a non-metal. So that tells us it's ionic, binary ionic. Now that we've classified them, we can start naming. We'll start with the ternary ionic compound first because that's a little bit more difficult. Calcium. Is it a transition metal or no? You can just write TM or no. Or na if you want to. So transition metal or na. It's not a transition metal. So that means that we can look at the periodic table and figure out what its charge is. What is the charge for the calcium ion? This is just extra practice. This isn't necessarily part of naming. Yes, it's 2+. We need this information. So calcium is 2+. And the way that we name that is the calcium ion. Now we need to identify this polyatomic anion. Look at your sheet and tell me the name of the ion and its charge. So this is the nitrate ion. It's got a charge of -1. We established that the calcium ion has a charge of +2. I want you to notice that there are 2 nitrates. So when we look at the total charge from the anions, we've got -2. I'm going through this because you're going to need to know this when we do writing chemical formulas. It's easier when you're doing the naming than when you're doing the chemical formula. So does everyone understand how we figured out this is the total charge for the cation and the anion? Calcium, we know that from the periodic table. Nitrate, you get that from the chart, and then you have to see how many you have. So let me know if that makes sense. For naming purposes, can you explain that question a little bit for me, Cameron? What do you mean by the O not changing? So we're not looking at the elements separately. We're looking at the nitrate ion all together. So the nitrate ion has a charge of -1. the total charge from both of the nitrates is -2. We're not looking at the individual charges of the nitrogen and the oxygen. We're looking at it as a whole entire unit. Does that make more sense? Yeah. So don't try to separate anything out when you're looking at a polyatomic anion. You're looking at it like it is one unit. So for naming purposes, we have all our information. We have the calcium ion, the nitrate ion. You get rid of the word ion, and you put them together. But what we were doing with the charges, we're going to need when we start writing chemical formulas from the words, from the name. So I just want to introduce that and get you comfortable with it. And you will need more practice with it, which is why I introduce it here. Does the naming make sense? A little, that's okay. It's going to take practice. Does it make a little more sense than it did before? That's what we're going for. We're going for little improvements. Alrighty. Let's move on to the second one. I want you guys to try it. So try naming this compound. It's a binary ionic compound. Name the cation. Then name the anion. And put them together. I'm going to get started, but if you're not finished, that's okay. I just wanted you to have a little bit of a head start to try to name this compound. The K is our cation. It is a representative element in group 1A. So that means we don't have to use the stock system. To name it, it's just the potassium ion. Now we're going to look at the anion. That's an S for sulfur. We're going to keep the first syllable, get rid of everything else, and add IDE. So that's the sulfide ion. Get rid of the word ion. And you get potassium sulfide. So for those of you who are still with me, does that make sense? How did that one feel? And if the answer is not good, you can say that. That's okay. I'd like to know that too. Yes, with all monoatomic anions, you're going to take the first syllable and add IDE. Okay. Yeah, ironically, I didn't think about this until just now, but this blue and black, this is actually my home high school colors. So I didn't actually go to the high school in my town because I was like, I want to go to college and they ain't going to prepare me. But I did participate in extracurriculars like band and stuff. And so we were the Blue Bishops. It's like a bishop is peaceful. We trying to be out here playing football and stuff with a blue bishop. It made no sense. But at the time, it was lit. I don't remember what we called it back then, but it wasn't lit. But yeah, blue bishops. Black and blue. I don't know who thought that was a good idea. Anyway, we wrote the name from the chemical formula. Now we've got to go in the opposite direction. Take the name and write the chemical formula. So remember that an ionic compound has positive and negative ions. And we were kind of doing that with the ternary ionic compound, when we were looking at the different charges of the components of that compound. Remember that the total positive charge must equal the total negative charge. So you add up the charge of all your anions, all your cations, and it better be equal but opposite. So if you have a total of positive 6 for your cations, then you need to have minus 6 for your anion. That is very, very key here. So now I'm going to show you how to go from the chemical name to the chemical formula. You have to kind of unpack the name. Calcium sulfide. This is our cation, the calcium. The sulfide is the anion, and you can tell that because of the IDE. So it's a monoatomic anion. This helps us because now we can put some symbols to this. If we were to break this apart, we would have the calcium ion and the sulfide ion. Let me try to keep my color scheme here. We already looked at calcium and we said that it is group 2A. Because we know its group and that it's in the representative elements, we know its charge just based on the group number. So that ion looks like this, calcium 2+. So we're taking each ion and writing out what it looks like as a chemical symbol. Is everybody with me on how I went from the word calcium to calcium ion to writing out the formula? Okay. Now let's do the same thing for the anion. We have the sulfide ion. This sulf tells us that we're looking at sulfur. What group is sulfur in when you look at the periodic table? What group is sulfur in? It's in group 6A. How do we figure out the charge? Our charge is going to be the group number minus 8. So 6 minus 8 is -2. So the sulfide ion looks like that. It's the S, which is the symbol for sulfur, with a 2 minus. With our total charge here, we've got 2 plus for the cation, 2 minus for the anion. So they're equal but opposite. That means for our chemical formula, we're going to have one of each. So this is the formula for calcium sulfide. Are we good with that example? I have another example, but are we good with that one example, or do I need to run through that again? Everybody else wake up. If you don't speak up, then I don't know. Thank you. Let's do another example. This time we're doing iron 3 oxide. We've got our cation, that's the iron. The anion is the oxide, and from the way that it's named, we know it's a monoatomic anion. Notice here that with the iron, we've got the 3 in parentheses as a Roman numeral. This means that we're looking at a transition metal. So we don't have to do anything to figure out what the charge is. That 3 tells us the charge. So for our iron 3 ion, it's Fe3+. So that's going backwards from the name to what the ion looks like. Oxide, ox comes from somewhere. Comes from oxygen. Oxygen is also in group 6A. So that means that its charge is going to be -2, just like the sulfur. So that ion looks like that. Now we look at our totals. If we had just one iron 3 ion, we'd have positive 3. If we had just one of the oxide ions, we'd have negative 2. That's not balanced. So what we have to do is find the lowest common denominator. Which is LCD. If you remember fractions when you were in school, finding the lowest common denominator. What's the lowest common denominator for 3 and 2? And if you don't remember what that is, you can say, I don't know. Yeah, the lowest common denominator is going to be 6. So that's a number that both of these are divisible by. Or this number is divisible by both of these. And it is the smallest number that we can divide both of these numbers into. So that means we need to have a +6 charge for the iron and a and a -6 charge for the oxide. Here we're going to multiply by 2. And then for the other one, we're going to multiply by 3. These two numbers are the subscripts for your different ions. So you have to have 2 iron 3 ions and 3 oxide ions to have a total neutral charge, the +6 and -6. Now there's another way to do that, which does this method, but without actually walking through finding what the lowest common denominator is. If you can figure out what your 2 ions look like, and you know that you have to have some multiple of these because your charges do not match up. You're going to take this 3, that's the charge of the iron, and drop it down there for the oxygen. The 2 and the 2- for the charge of the oxygen, you put as the subscript for the iron. So whenever the charges do not match, then you can swap them. You take the charge of the cation and make it the subscript for the anion. And the same is true for the anion. You take that and make it the subscript for the cation. Talk to me about this one. How do we feel about it? Okay. One more example. And we're still in binary ionic compounds. Let's deal with our cation. It's calcium. We've seen this before. So we know already it's 2+. The nitrate ion, that's our anion. So this is a ternary ionic compound. The others were binary ionic compounds. You look at your chart to figure out the chemical formula and the charge for the polyatomic anion. These do not match. They're not balanced. So we have to make sure that they are. The lowest common denominator is 2. When we write our formula, we're going to have only 1 calcium, but we're going to have 2 nitrate ions. The way that you do that is by putting the whole nitrate ion into parentheses, and that says it's 1 unit. Then you put a 2 on the outside of that to show that you have 2 nitrate ions. How does that one feel? That's a ternary ionic. So it's very similar to what we just did. I want you to try this one. So I want you to write the chemical formula for iron 2 phosphate. I'll give you 2 minutes and then I'll check in. Looks like we've got one answer. Yeah, it's a little hard to put the subscripts into the chat, so I understand. I'm going to get started on this one. So our cation is going to be the iron 2. And since it's using the stock system, we don't even have to look at the periodic table to know what the charge is. 2 plus. For the phosphate ion, you look that up on your chart. And that's PO4 3 minus. When we're looking at our charges, we've got 2 plus and 3 minus. Those are not equal but opposite. So we find our lowest common denominator, which is 6. So we have 3 iron 2 ions and 2 phosphate ions. And to show you with the where you just kind of take the charges of the different ions, I'll write that out too. Oops, that should be a 2. So you should have Fe3, and then in parentheses, PO4 with a 2 after it. That is how you would write the chemical formula. So those of you who participated, you got the idea. Just don't forget that PO4. It'll be multiple choice, and that could be one of the choices, but it's wrong. So Fe3, that would be wrong, as well as this. So all of those things would be incorrect. You got to pay attention to detail here. So that's binary ionic and ternary ionic. Those are all the ionic compounds. Those are the most difficult to do the naming and writing chemical formulas for. Everything else is pretty easy. So we're going to move on to the binary molecular compounds. Remember that those just have 2 non-metal elements. With naming, you're going to name the first element first, and then the second element has the IDE at the end of it. The way that you indicate how many of each element you have is by using a prefix. And the prefixes are all in this chart here. The only exception is for mono. We don't use mono for the first element. So if there's only one of the first element, you just write the element name, and I'll show you an example of that. You're not going to get this chart. Most of these, or at least a good number of them, you already know. So I'm not going to provide this chart for you. Make sure that you do know these prefixes. So I'm going to walk you through naming a couple of compounds. We already know it's a binary molecular compound because there's 2 elements and they're both nonmetals. We write down the name of the first element. There's no subscript here, so that means there's only one. But we don't write mono here. We just write carbon. The next element is oxygen. And you're supposed to take the element name, just like naming the, what are they, the monoatomic anions. It's the same exact thing here. You use the first syllable and add IDE. We also have to indicate how many oxygen atoms there are in this formula. And there's 1. Now, oxygen is a little funky. You don't write monooxide, you just write monoxide. So when you write it all out together, this is something that you should kind of recognize. Carbon monoxide. Notice that there's only 1 O in that position, not 2. I'll do another example for you. Let's deal with the first element. There is a subscript here. There are 2 nitrogen atoms. That means we're going to use the prefix di, which is 2, followed by the whole element name, nitrogen. For the second element, we know that there's 3 of them. Tri is the prefix for 3. We take the first syllable of oxygen and add IDE, dinitrogen trioxide. How does that feel? And you'll have the opportunity to name some for yourself. I just want to make sure that if you need me to go through these examples again, I can. So we're going to cover the acids, and then the last slide that I have for you is a practice slide. And depending on how much time we have, we may be able to go over a few of those, but I'll make sure to have the answers in the annotated notes that I post on Blackboard. So if we don't have time to go through all of them, you can use them for practice and then check your work. So binary acids, remember that's Ba. We're looking at an aqueous solution, so that's the AQ, and it's got hydrogen plus a nonmetal. You're always going to have that hydrogen first with an acid. When you're naming a binary acid, you're going to use the prefix hydro, which is for hydrogen, and then add the element stem of the nonmetal. So what the heck does that mean? We've got HF here and it's aqueous. You're going to start with hydro. Then you're going to add the element stem, which is like that first syllable. So for fluorine, it's fluor. Then you add IC at the end of that word. So hydro, then your first syllable from the element, the nonmetal element. Then you add IC. You follow that with the word acid. So using that same technique, how would we name the second acid? You can write your answer in the chat. What would the name be for this acid? Start with the hydro. It's iodine, so we're going to keep the iode and add IC. And don't forget the word acid. Because if you just give me the first word, that's not the complete name. Now let's do the ternary oxyacids. They're still going to have that aqueous there. It's going to start with the hydrogen, just like the binary acids. But we're going to have that oxyanion or that polyatomic anion. And the naming is a little bit different. So this is why you need to know the difference between the ate and the ite form. We use the polyatomic anion to name the acid. The anion that this is derived from is nitrate. So you identify that first. Then you look at the ending of the oxyanion. We have an ATE here. So we're going to get rid of that and replace it with IC. You replace the word ion with acid to make nitric acid. We do a very similar thing for the ite form. So this is from NO2 minus. It's got one less oxygen than the ate form, so it's the ITE. We get rid of the ITE and replace it with OUS. Replace the word ion with acid. And you get nitrous acid. Were those examples clear? ATE versus ITE. So there's a lot of rules thrown at you, okay? So now we've got some practice. This is for naming the binary acids and ternary oxyacids. So I'll give you 2 minutes to try naming these 3 compounds, and then I'll check back in. In the interest of time, I'm going to go ahead and write out the names for these, and you can check your work. So this first one, we've got hydrogen plus a polyatomic anion. So that's going to be a ternary oxyacid. Now I know what rule set I need to use. I'm going to find this ion on my sheet. It is the chlorate ion. For an ATE anion, you're going to get rid of the ATE and replace it with IC. Replace ion with acid. So your first one should be chloric acid. The second compound, we've got a hydrogen plus a nonmetal. Only 2 things. Starts with a hydrogen, it's got the aqueous, so it's got to be a binary acid. We're going to start with hydro, because that's how binary acids all start. We're going to look at what this nonmetal is. It's bromine. The first syllable of that, we're going to take the brome and add IC. Then we add the word acid for hydrobromic acid. The third example, we again have a hydrogen plus a polyatomic anion. So that means we've got a ternary oxyacid. You look up this anion. It's the sulfite ion. You replace the ITE with OUS and ion with acid. So your answer should be sulfous acid. Now, in your chemistry dealings, you may see an alternate spelling with a pH. Same thing. Same thing. So how do we do on those? Did we get at least one right? With naming with this chapter, it just takes a lot of practice. So in addition to the chapter check-in, I'm going to be posting some worksheets for you to be able to practice naming and writing chemical formulas and classifying. That is really the only way to get through this chapter. So I'll let you know when I post that practice and the answer key. Here's some more practice. I'm going to say that we do maybe the first two because I want to have some more time for going over the reminders. So we'll do these two, and I'll make sure to have the answer for the last one in the PDF before I post it. So take 2 minutes, classify these first two compounds, and write out their chemical formulas. For this first compound, what kind of compound is it? Yeah, so we're looking for the classification first. But I see your answers for the chemical formula. We've got 2 elements, 1 metal plus 1 non-metal. So that is a binary ionic compound. I already saw some answers for the chemical formula. We've got the iron 2 ion here. The oxide ion is O2 minus. And since those match up, they're balanced, FeO. That's the chemical formula. What about this second compound? How do we classify it? We've got 2 elements. They're both non-metals. The only option for that is binary molecular. Now we have to go backwards from the name. So this is why you need to know your rules and you need to know those prefixes. Phosphorus trichloride. We don't see any prefixes for the phosphorus, so it's just a P. Chloride, we know comes from chlorine. So that's the element symbol we'll use there. And the tri means 3. So PCl3. That's how you go backwards for that one. How do we feel about that? So I'll throw up the answer here for this third one. Calcium phosphate. The calcium ion, we've done that one a few times. That's Ca2+. Phosphate, you're going to look that up on your chart. It's PO4 3 minus, and those are not balanced. So your lowest common denominator here is 6. You're going to have Ca3 PO4 in parentheses with a 2 after it. That's naming. Naming and writing chemical formulas. You have a chapter 6 check-in, which is pretty much like what we did on this last page, where you have to classify a compound and then either write the name from the formula or write the formula from the name. So you've got, I think, 3 examples of each. And then your Mastering Chemistry Chapter 6 assignments are due by the end of Sunday, October 4th. I know y'all just took an exam, but next week is exam 3, and that's on chapters 5 and 6. So we've done all the material for chapters 5 and 6, so you can start studying for that. And part of that studying will be doing the chapter 6 assignments. Yay! As usual, I will post the exam review. We'll do a little bit of exam review, and we'll start chapter 7. I will warn you, you need to keep chapter 6 in the back of your mind for chapter 7. We are building on everything that we do. So you need to keep the naming in mind. You need to keep the balancing the ions and writing the chemical formulas, because we're going to need that for balancing equations and for writing chemical equations in words, which is what we're doing in chapter 7. Your exam 3, again, is going to be available next week, Wednesday, October 7th through Friday, October 9th. I will give you a periodic table, a plain one, and you'll also get those common ions. So that chart I told you that I put into the in for the content, you're going to get that along with the periodic table to take exam 3. Are there any questions about that? I want to throw in one more reminder here. Course messages. To send me a message through course messages, you got to find that under communication. It's on that blue sidebar. You click on that, and then you want to click on Create New Message. It's near the top. From there, you want to click on the little button that has 2. And that will give you a drop-down list of all the people that you can send a message to. If you want to send me a message, you click on my name, and then you click on the little button that looks like that. And that will add me to the recipients list. Then you write your message below. You can attach things just like you would in a normal email. And that way you won't get a response from me saying, hey, I'd love to help you, but you need to send it to me in course messages. I check it multiple times a day. On the weekend, not as regular. You know my hours, it's in the syllabus. So make sure that you use course messages when you're communicating with me. Otherwise, I may not see your email, and I likely, unless it is an emergency, my response will be, please send this to me in course messages. I know that's frustrating. It's frustrating for me to write. So please remember to use course messages. This is not my decision. It is the university. So do us all a favor. Get familiar with course messages. That's all I have for you. If you have any questions, you can put them in the chat or you can ask. Otherwise, you're free to go.